Hey guys, so today we are going over area and perimeter of 2D shapes. In class I gave you this worksheet, and so we're going to use this to take notes just because it has the nice pictures already drawn for you. So what I want you to do is to split this column here on the right into two. So just draw a line straight down the middle. Label one side area and the other side perimeter. So I'm going to give you formulas for both. You probably already know most of these formulas, but I do want to cover them anyways just because we're going to need them in class. And so first shape, obviously a square. I'm going to label the shapes as well, that way you know what I'm talking about later. In order to get the area of the square, just length times width. In order to get the perimeter, well, all the sides are going to be the same, so I can just say 4 times my side equals my perimeter. Our next shape is a rectangle. Excuse my annoying cat. Come on. So in order to get the area of a rectangle, we do the same thing, still length times width for area. And then for perimeter, we have 2 sides that match, and then the other 2 sides match. So I can say 2 times my length plus 2 times my width. Or you can just add up all the sides, whatever works best for you. Next one is a parallelogram. We know this because all my sides are parallel, but there's not necessarily right angles. So when there's not right angles, it's just a parallelogram. We still get the area from length times width. And our perimeter is also the same, 2 times the length plus 2 times the width. For a triangle, our area of a triangle is 1/2 base times height. Oops, triangle. So when it's talking about height, make sure you're talking about the vertical height, not slant height. So whenever you do height, it has to be going up and down. And then for a triangle, because all my sides could be different, just add up all the sides. And it gives you your perimeter. Our next shape is a rhombus. Kind of looks like a slanted square. In order to get the area of a rhombus, length times width. Notice most of these are length times width, pretty easy to remember. And then in order to get perimeter, for a rhombus, all my sides are the same. So just like the square, 4 times my side, whatever my side is. It's just 4 of them. The next shape I have is a trapezoid. I might have spelled that wrong. We'll find out. Trapezoid. And in order to get the area of a trapezoid, you do base 1 plus base 2 over 2 times height. So what I mean by that, base 1 and base 2. And then same thing, your height still has to go straight up and down. That would be height. And then in order to get perimeter, a trapezoid, all your sides could technically be different, so we're just going to say add up all the sides. Our next one is circle. In order to get area of a circle, it is pi r squared. That's pi times your radius squared. From the distance from your center to the side is your radius. And in order to get perimeter, another word for perimeter when you're dealing with a circle is circumference. So I'm just going to write that in here. So that's another word for getting the perimeter of a circle. It's just the outside. In order to do that, it is 2 pi r, so 2 pi times your radius. Now, our next shape is technically a hexagon, but this rule applies for anything with 5 or more sides. So, anytime you have 5 plus sides, you would use this formula I'm about to give you, and it is 1/2 PA. Now, P stands for perimeter, and A stands for apothem. And an apothem is just segment that connects the center of a figure with the midpoint of one side. So that's what apothem is. This little line right here is your apothem. So it would be A. And so whenever you're given a problem like this, they will have to tell you what the apothem is, or you have to do a little bit of Pythagorean theorem to get it, but you have to use your apothem. So your perimeter, the apothem gets you the area. In order to get your perimeter, just add up all the sides. And for your perimeter, that's all it is in general, except for the circle. The circle has 2 pi r. All the rest of them are basically adding up all the sides. I know we have a 4s and 2l plus 2w, but that's just a fancy way of saying add up all the sides. So that's all we're really doing. So make sure you definitely know your area formulas. You will need your perimeter for circle, and then this one as well, but the rest of them are pretty much self-explanatory. So these are all of your formulas for getting area and perimeter of 2D figures. Those are just two-dimensional figures. How we're going to use them in Math 2 are going to be in situations such as these. So I give you this figure and it says find the area of it. Notice that's not really a shape we worked with. Technically it's a pentagon, but it's not a regular pentagon. So it's not going to work to use our apothem formula. So what we would do here is to break this into pieces. So one way I can do that is by using my dotted line. I can break it and have 2 trapezoids. I could do that. I could split it here and have a rectangle and a triangle. And I think I'm going to do that. But there's a lot of different options here. So there's not one set way to solve these. You do whatever makes the most sense to you. But basically, whenever you have an irregular figure, it's just a figure that's not a rectangle, square, circle, things like that. Whenever you have one of those, you have to break it up. So I'm going to do the rectangle first. So my rectangle is length times width, which is 5 times 10, gives me 50. That's the rectangle. And then to get my triangle, it is 1/2 base times height. Oops, base times height. So let's fill in what I know. That means I have 1/2. The base of my triangle is this blue line. Well, think about it, it's a rectangle. So if this side of my rectangle is 5, this side of my rectangle must also be 5. So my base of the triangle is 5. And then the height of my triangle, well, this side of my rectangle is 10, and this line going through the middle is 12. So if this section's 10, that means this section must be 10, which means if the whole thing's 12, this section right here must be 2. 2 plus my 10 gives me 12, which is the whole thing. So the height of my triangle must be 2. So I have 1/2 times base times height, and 1/2 times 5 times 2 is just 5. Cat, stop. And so this is my triangle. So if I add together the area of my rectangle plus the area of my triangle, That gives me the area of the whole thing. And then on the bottom, I have find the area of the shaded region. So I have a square, and inside of it there's a circle. But all I want is the area that's outside of the circle. So what we're going to do here is find the area of the square and then subtract the area of the circle out. So let me show you what I mean. So my square here, if my radius here is 4, notice that's about half the square. So that means my whole entire square must be 8. Well, it's a square, which means both my sides must be 8. Area of the square says length times width. So 8 times 8 gives me 64. That's the square. And then I need the circle. Well, area of a circle is pi r squared. So it's pi times 4 squared, which equals 16 pi. So, that's my circle. So in order to find the area of just the shaded part, I want to take the area of the whole square and subtract out the circle. So if I do 64 minus 16 pi, I get, give me 1 second. I got 13.76. In case you guys are curious, this is my cat. I'm going to just mind your business. So, that's how you get the area of just the shaded region. So we'll be doing more of these in class today. You have some in your packet, but you don't have to worry about those until we get to class.